Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have a new lesson in the algebra. Okay, it's Unit 1, Lesson 6. The lesson is the interval part 2, which is called the operations on the interval. In this lesson, inshallah, we are going to learn how to make two intervals union or intersection or finding the difference between them or finding the complement of the two intervals, and we are going to represent more than interval on the number line. Let's start the lesson. Before finding the operations or learning the operations, we are going to make a revision on the sets. Okay, this revision related to the sets as we studied in the primary stage. Okay, for example, if we have set X included three numbers 1, 2 and 3, and another set Y included 3 and 4, and another set U included 1, 2, 3, 4, 5 and 6. Okay, here we have U is called the universal set, okay, which included X and Y inside it. Okay, 1, 2 and 3 inside, and 3 and 4 are also inside universal set. To represent the three sets on by using a Venn diagram, okay, as we studied before, like this. X represented by oval like this included 1, 2 and 3, and Y represented by another oval like this, but we have here 3 written only one time because 3 is a common element between X and Y. Okay, find to represent the U. Okay, we are going to draw a rectangle like this or oval like this included X and Y, and 5 and 6 here are not belong to X or Y, they are outside X and Y. Okay, now the first operation, this one is called intersection. Intersection means the common elements. X intersection Y, or the common between X and Y. Now to find the common between X and Y, it's clear that 3 is the common element between them. Okay, represented here. Okay, now I represent the intersection inside a set like this. Okay, number 2, X union Y. X union Y means all the elements inside X or Y. Again, all elements at X or Y. Okay, now we have 1, 2 and 3 inside X, 3 and 4 inside Y, then X union Y. We will take all the numbers at X or Y, 1, 2, 3 or 4. Okay, like this. Now the third relation called X minus Y or X difference Y. That means the elements that belongs to X and doesn't belong to Y. Again, elements at X, not at Y, or by another meaning, I will say X only, at X only. What is the elements are inside X and not inside Y? They are 1 and 2, because 3 included in both of them. Then we are going to take 1 and 2 like this. Okay, another direction for the difference, if we have Y minus X. Y minus X, that means at Y, not at X, like this. Okay, what is the element that included at Y and not included at X? It's 4, like this, inside set. Okay, finally, we have a relation, okay, represented like this, X dash, which is called X complement. That means all the element that doesn't belong to X. Again, all elements that don't belong to X. Okay, here we have X included 1, 2 and 3. All the elements outside X, they are 4, 5 and 6, because I'm going to take all except X. All except X, I'm going to take 4, 5 and 6. Okay, if we have Y dash, all except Y, all elements except y. Y included 3 and 4. I'm going to take the other elements but 3 and 4, which is 1, 2, 5 and 6. Again, all elements without 3 and 4, they are 1, 2, 5 and 6. Okay, now don't forget this remark. The results are always sets, because I am going to make operations on sets, then the result will be a set. Okay, if we make operations on intervals, then the result must be intervals in most of cases. Okay, let's solve problems about this one. Okay, in this example, okay, we have x is interval from 2 closed to 5 opened, and y is another interval from -1 closed to 3 opened. Okay, the first step was us, I'm going to represent the elements, okay, in the number line like this. We have two different ways. We can write all numbers -1, -2, -1, 0, 1, 2, 3 and so on, or we can write only the numbers on the intervals, and this is the better way. Okay, I'm going to write the 4 numbers 2, 5, -1 and 3, but in order. The least number here is -1. Okay, and then I have 2, I leave space and write 2, and then 3, finally here 5. Okay, the first step, the first interval, I will represent it above the line like this by, for example, the red color. It will be 2 closed like this here, and 5 opened here, and then I will connect them like this and shade the space between the two sets like this. Okay, okay. Number 2, I have here by another color -1 closed. It will be shade like this, and 3 opened like this, and then I will shade between them. Okay, now we have the two intervals. Okay, the first one, don't forget the upper one is x here, this is x, and the lower one is y here. Okay, I will divide this one into 3 places. The first place, the place included between the two intervals. Okay, the area included the two intervals together. Here we have red color here and green color together. Okay, the second area, this one, the second area which included green only, the third area which included the red only. Okay, the first one here, x union y. X union y means all elements included at x or y. Now I'm going to take all the numbers at x or y. All the numbers are -1 and all the numbers till 5. Okay, then in the union we are going to add the numbers in one interval. Okay, and I'm going to write the first and the end. Okay, it will be from -1 till 5. Okay, -1 here is shaded, then it will be closed, and 5 here is opened, then it will be opened like this. The second one, x intersection y. As I said before, x intersection y means the common elements between x and y. The common elements here represented in this area. Okay, all the elements included in both of them, because we have here the red numbers and the green numbers in one interval like this. Okay, it will be from 2 till 3. 2 here is closed and 3 here is opened. Okay, the third one, x minus y. X minus y. Here the x interval, it's the red one, and y interval is the green one. X minus y, we am going to subtract y from x. Subtract y from x. I will cancel the whole y. This is why I will cancel the whole y like this. Okay, then the remainder, this part. Okay, again, I will subtract y from x, or I will take the elements belongs to x, not belongs to y. To subtract y from x, then I will cancel all y up and down like this and take the remainder. The remainder, it will be from 3 to 5 as we see. Okay, it will be like this, equal from 3 to 5. Okay, 3. Now x minus y, I will take the elements that belong to x and do not belong to y. Okay, here 3, okay, which belong to x, it exists up or down, it's here, it's up. Okay, here 3 belong to x and do not belong to y. Okay, if the number belong to x and do not belong to y, then I will write it in the answer. Okay, because I take the element which belong to x and do not belong to y. Okay, then I'm going to take 3, it will be closed like this. Here 5 doesn't belong to x, then it will be closed. Okay, again, if the element belong to x and do not belong to y, it will be written in the answer. It will be right in the answer. Okay, if the element doesn't belong to the first, then I will make it open in the second one. The next one. Now I need to write y minus x. Y minus x means subtract the whole x from the number line like this. Subtract the whole x. Okay, to subtract the whole x, the remainder is what? The remainder is from -1 to 2. Again, I will subtract the whole x, okay, from the number line. It will be from -1 to 2. Okay, it's from -1 to 2. Here -1 exists in y, then I will make it closed. And 2 here belong to y, and in the same time it's belong to x. Again, it's belong to y, and in the same time it's belong to x. Then I will not write 2 in the answer. Again, 2 belong to x and belong to y, then I will not write 2 in the answer, then 2 will be opened. Okay, the next one, x dash. Remember with me, x is from x here from 2 to 5. To solve x dash, I will write 2 in another, I will write x in another number line like this. It's from 2 to 5, and 2 here is closed and 5 is opened. And 5 is opened. This is x. Here we have positive infinity, and here we have negative infinity. Okay, x dash means all the elements inside X. Again, sorry, all the elements outside X. Okay, here we have outside X, we have this area and we have this area. Okay, then I will write the numbers outside X. It will be from negative infinity till 2. Okay, union from this area, it's from 5 to infinity. Okay, here negative infinity is opened, always opened. 2 belong to X, then it doesn't belong to X dash. Okay, then I will make it opened. 5 here is not exist in X, then it exists in X dash. Okay, again, if the element belong to X, then it will not belong to in X dash. If the element doesn't belong to X, then it belongs to X dash. Then 5 here is closed. Okay, another example. Y here is from negative 1 closed to 3 opened. Then I will represent Y here from negative 1 closed to 3 opened, like this, and I will connect. This is Y. Okay, here we have negative infinity, and here we have, sorry, here we have positive infinity, and here we have negative infinity. Okay, as I said before, Y dash means all the numbers outside Y. Okay, outside Y we have two areas. We have this area, this numbers from negative infinity till negative 1, this area. Okay, from negative infinity to negative 1. Negative infinity is always opened. Negative 1 exists in Y, then it's not exist in Y dash, then it will be opened. Okay, union okay, union, the other area, this one, it's from 3 to infinity. Okay, from 3 to infinity, but 3 here is not exist in Y, then it's exist in Y dash. Negative infinity, it's always opened. Okay, then this is the answer of Y dash. It's from negative infinity opened to negative 1 open. Another example, if we have X from negative infinity to 3 and Y from negative 4 to infinity. First, I'm going to represent X above the line like this. I will write the numbers here, negative infinity, negative 4, 3, and infinity here. Okay, next I will represent X from 3 closed here to negative infinity in this direction, like this. This is represent X. Okay, and here we have Y in this direction. It will be closed here and till negative 4 till the end of the line, like this. Okay, this is x in the upper one, and this is y in the lower one. Okay, now I need x union y. X union y means all the elements, okay, all the elements at x or y, we are going to add x and y together. I'm going to take all elements at x and y. It will be from negative infinity till infinity, okay, negative infinity till infinity. As much as you take all the elements of x and y, or you add the two lines of x and y in one line. Okay, number two, I'm going to take the intersection between them, x intersection y, okay, the elements in between, which belong to x and belong to y in the same time, it's from negative 4 to 3, negative 4 to 3. Negative 4 here is closed, and 3 is also closed. Okay, the next one, x minus y. X minus y, I'm going to take all, I'm going to subtract y from the number line like this. I'm going to subtract y, subtract the whole y from the number line. Then the remainder will be from negative infinity till negative 4. Again, if we subtract y from the number line, the remainder will be from negative infinity till negative 4. Okay, like this. Okay, here negative infinity doesn't belong to x, it's always opened. Negative 4. Negative 4 here belongs to y and in the same time belongs to x. Then I will not take negative 4, then it will be opened. Again, I will not take negative 4 because negative 4 exists inside y. Okay, y minus x. Y minus x, I will subtract x. I will cancel x from the number line like this. I will cancel x from the number line like this. Okay, then the remainder will be from 3 to infinity. Equal 3 to infinity. 3 here exists, it's belong to x and belong to y. Then I will not take 3 because 3 is a common element. Then I will not take it, that it will be open, and infinity always open. Okay, now I need to represent x dash on the number line. Represent x dash. X is from 3 closed to infinity like this, to negative infinity. This is x. Okay, then the other part of the line is x dash. Then x dash equal from 3 to infinity, from 3 to infinity. But here 3 belong to x, then it will not belong to x dash. It's not exist in x dash, it will be opened. Here infinity is always opened. Okay, y dash, y here is from negative 4 to infinity. Then I will represent y on the number line like this. Y from negative 4 closed till infinity. Okay, this part is y. Then the other part of the line is y dash. Then y dash is from negative infinity to negative 4. It will be equal negative infinity to negative 4. Negative infinity, okay, is always opened. Negative 4 belongs to y, then it will not belong to y dash. It will be opened here. Okay, the next example. Okay, now we have operations on intervals but nameless. Okay, then I will represent each one on the number line. Here we have negative 1 and infinity. I will represent negative 1 and infinity here on the number line. It's from negative 1 to infinity, like this. Negative 1 closed and infinity opened. Okay, this is the first one. The second one is from negative 3 closed till 4 closed. Okay, now I need make them union, then I will add them in one interval. Then this interval will be start from here till here. Okay, I will add them in one interval. It will be like this, from the very start to the very end like this. Okay, it will be equal negative 3 closed till infinity opened. Okay, the next one. Here we have 2 and infinity intersect negative 2 to 3. 2 here. Infinity. And here negative 2, 3, opened each. Okay, the intersection means the common area in between the two intervals. Here the common elements here. Okay, like this. It will be from 2 closed till 3 opened. Okay, the next one. It will be from negative infinity to 3. Here we have 3 closed, negative infinity in this direction. And the other one from negative 1 to infinity, negative 1 closed to infinity opened. Okay, now I'm going to do what? I'm going to subtract the second from the first. Again, I will subtract the second from the first. The second, which is the red one, I will subtract all this one. I will subtract all these numbers from the first. It will be, the remainder will be from negative infinity to negative 1, like this. Negative infinity to negative 1. Okay, here negative infinity is always opened. Negative 1 belong to the second and belong to the first. It's common, then I will not take it in the answer. It will be opened. The next one. Here we have negative 2 and 4. I need the intersection between them. Negative 2 closed, 4 is closed, and the other one, 4 is closed and 6 is closed. Okay, the common here, the intersection means the common. This one is the common, it exists up and down, then it will be 4 only. Okay, 4 only to represent number, only one number in the answer of the interval, it will be set 4 like this. Okay, the next one, here we have 3 and 5 intersect, 3 and 5 set. Okay, I can answer this one without represent on the number line. Why? Here we have, in this interval, I have 3 parts. I have the number 3 and the number 5 and the elements between them. And here we have 3 and 5 without the between. Then the common here between them is 3 and 5. Okay, to make it easier, I will represent on the number line like this. Here I have in the first one 3 and 5. Interval. This is the first one. Intersect 3, the element 3 and 5 set. I will represent it by dot only, like this. Then what is the common? The common here is number 3 and number 5. Again, the common is number 3 is common, number 5 is common. To represent 3 only and 5 only, it will be represented by set, like this. It will be set 3 and 5. The next one. Here we have 3 closed and 5 closed minus. Oh, I can represent this one, I can study this one on this number line. Okay, I will not need this one. Okay, by using this number line here, 3 and 5 closed, it's 3 and 5, 3 and 5 and the between, 3 set 3 and 5, set 3 and 5. Okay, now I need to subtract the second from the first. I will subtract here, subtract 3 like this and subtract 5 like this. Okay, and I will the numbers between. Then I will take all the numbers between 3 and 5 without 3 and 5. Again, I will take the numbers between 3 and 5 like this. It will be 3 and 5. If I need the numbers between 3 and 5, it will be opened because I need not a 3 or 5. Another example. In this one, I have 3 and 5 closed minus 3 closed and 5 opened. Okay, I will represent the first one up here, 3 and 5, 3 closed, 5 closed, and connect. The second one will be 3 closed, 5 opened, and connect. Okay, I will subtract the second from the first. Again, I will subtract the second from the first. I will subtract all this from the first. The remainder will be number 5 only. Okay, or what is the increase of the first than the second? The first included 5 more than the second. Okay, and this is the difference. Then the answer here is 5 only. It will be represented by set like this. The next one, here we have 3 and 5 and 4 opened, union 3 and 4 like this. Okay, the first one on the number line like this, 3 closed till 4 opened, the second one 3 opened, 4 closed. Okay, I will union means add. I will add the first and the second in one interval. Then we have here 3 and we have 4 and the numbers between them. Okay, to represent this one on an interval, it will be 3 closed because 3 exists here, and 4 closed because 4 is closed here, exists here. Okay, the next one, here we have 2 closed, 7 closed, minus 2 opened, 7 opened. Okay, I will represent the first one here, 2 to 7. The second one down, okay. Now I will subtract the second from the first. Again, I will subtract the second from the first. I will subtract the between. Okay, subtract this one. Okay, then the remainder will be number 2 only and 7 only. Again, by subtracting the between from both of them, the remainder will be 2 only and 7 only. Then they will represented by set like this, 2 and 7. The next one, here we have 2 and 5, 2 opened, 5 closed. Okay, I will represent the first one on the number line here like this, 2 opened, 5 closed like this, and the second one here, 2 closed, 5 opened. Okay, what is the intersection between them? 2 here is not common, 5 here is not common, but the between them is common. This is the common elements between them. Here, this is the between only. To represent the between on the number line, I will write it open interval from 2 to 5. Okay, now R intersect negative 3 and 3. R represent the whole number line. Okay, this number line is R. The whole number line is R. The second one is from negative 3 closed till 3 closed like this. The common elements between them, the elements included here, this is the common elements between them. Then the common elements from negative 3 closed till 3 closed. the next one. R negative minus negative 3 and 1. Remember with me, what's R negative? R negative is 0 opened till negative infinity, like this. And from negative 3 to 1, negative 3 closed, 1 closed, okay. Now I'm going to subtract the second from the first. I will subtract from negative 3 to 1, subtract all this, subtract this one from the first. The remainder will be from negative infinity to negative 3. Again, the remainder will be from negative infinity to negative 3, like this. It will be from negative infinity to negative 3. But here, negative 3 belong to the two intervals, then I will not take it in the answer. Then it will be opened. The next one, negative 2 and 5, negative 2 and 5, negative 2 opened, 5 closed, like this. Okay, minus R positive. R positive is from 0 to infinity. 0 opened to infinity. This is R positive. I will subtract the second minus from the first. Again, I will subtract the second from the first. Subtract the second from the first. The remainder will be from negative 2 to 0, like this. Okay. But 0, negative 2 here is not exist. It's not exist in the first one. Here, negative 0 is not exist in the second one and exist up in the first one. Then I will take it in the answer, then it will be closed. Okay, the next one, and here we have R negative intersect negative 3 and 2. R negative is from 0 opened till negative infinity. This is R negative, and the other set from negative 3 closed till 2 closed. Okay, the common elements here are the elements from negative 3 and 0. This is the common elements here. Okay, it will be from negative 3 till 0, negative 3 closed and 0 open. And this is the end of the lesson. I hope it was helpful for you. See you in the next video, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.